We propose an approach for intrinsic decomposition of RGB-D images on smartphones. As a pre-processing step, we remove the specular highlights in the input image, decomposing it into diffuse and specular components. Note the interactive specularity removal happening on the device. The diffuse part is further decomposed into albedo and shading by an efficient intrinsic decomposition optimization, which makes use of the corresponding depth data. The computed intrinsic layers are fed into our material editing framework, allowing for manifold image manipulations. Here we show few such examples, such as surface smoothing, recoloring, and transparency. Using the given depth data, one can also perform atmospheric appearance editing by introducing virtual fog in the scene or relighting the scene with God rays using a depth-based occlusion map, as shown here. The user can also stylize the input image using the decomposed intrinsic layers. Here we show few such enhanced stylization results. Our full framework looks as follows. The specularity is removed from input image, decomposing it into diffuse and specular components. The diffuse part is further decomposed into albedo and shading using a depth-based optimization. The intrinsic layers of specularity, albedo, and shading, along with the depth data, is used to showcase image editing applications. For specularity removal, we process the chromaticity and intensity of input image separately. As the first step for our novel specularity removal method, we identify specular pixels in the form of a specular mask. The image intensity is decomposed into subbands, and by reducing the positive coefficient for specular pixels, we are able to significantly remove the specular intensity. For specular pixels, chromaticity information might be reduced or missing, and thus we perform an iterative bilateral hole filling to inpaint the missing information. The output chromaticity and intensity is fused together to get a spatially consistent diffuse output. For decomposing the diffuse image, we perform an energy minimization and use inertial proximal algorithm for non-convex optimization to ensure albedo sparsity. Please check our paper for details about individual energy terms. We perform qualitative and quantitative evaluations. Here we show some qualitative comparisons. Our specularity removal performs better than the state-of-the-art in terms of accuracy and performance. Please note that our output is the most diffuse while being artifact-free and spatially consistent. Our intrinsic decomposition results are comparable to the state of the art while performing faster than prior works. The computed layers of albedo, shading, and specularity is used to showcase applications such as material appearance editing. Depth data is used for the purpose of atmospheric appearance editing in the form of virtual fog, or by relighting the scene as God rays. We can also mix the virtual fog and God rays to generate more aesthetic results. The decomposed layers can also be used to generate enhanced image stylization effects, as shown here. Please read the paper for more details. Thanks for watching.